chemical equilibrium. So first, we are going to learn about dynamic equilibrium. Before we learn the meaning of word equilibrium, we should know what is reversible and irreversible reaction. For reversible reaction, chemical reaction will take place in two directions, meaning reactant can become product. At the same time, product can also form reactant. Okay, so when reactant forming a product, we call this one as forward reaction. So when product forming a reactant, so that one we call it as backward reaction or reverse reaction. Okay, so for reversible reaction, the reaction do not proceed to completion. Okay, so for irreversible, the reaction only proceed with one direction, meaning reactant dissociate to become product, one direction only. So we will use this arrow to indicate this is the irreversible reaction. Okay, for reversible reaction, we will use this arrow. So in this chapter, we will learn about reversible reaction. Okay, so for reversible reaction, the reaction will occur until one time. The reaction will proceed to equilibrium. So what does it mean by equilibrium? Equilibrium is a state of chemical equilibrium where both forward and reverse, okay, forward or backward reaction proceed at equal rates. So at equilibrium, rate of reaction for forward is equal to rate of reaction for reverse. So features or characteristic system in equilibrium are concentration of reactant and product are constant over time. Okay, so rate forward equal to rate reverse, Q is equal to K. So we consider a graph of concentration versus with time. Okay, so A is reactant, B is product. So initially, reactant will have some value. So when you want to make any reaction, so we will take the reactant first. So at initial state, reactant will have some value. So product will have 0. So initially there is no product form. So as the reaction proceed, reactant will be decreasing. So reactant will be decreasing while product will be forming. Until one time, okay, at T equals to 1, concentration of product and reactant are constant. So at this point and forward, we say that the reaction already achieved equilibrium. Okay, equilibrium means that concentration, reactant and product are constant. Okay. However, there is a case where concentration, reactant and product constant at the same time they have similar value. Meaning, okay, so this is your reactant. Initially reactant has value, so decrease over time. So product is 0 initially, so increase. Okay, so at equilibrium, so this is where reaction already achieve equilibrium. So at equilibrium, reactant and product, concentration of reactant and product are constant. But in this case, concentration, reactant and product are similar, accidentally similar. Okay, so we will have this graph. If you have several reactant or if you have several product, the graph should be the same. For example, I have several reactant and forming several product. Product is always increasing, reactant is always decreasing.